Good afternoon, everyone. Thank you for coming to my talk on enabling contextual soft moderation on social media through contrastive textual deviation. This work is done with my collaborators at Boston University. So let's begin. Social media platforms such as Facebook, Twitter, TikTok, they employ warning labels underneath misleading posts to provide users additional context about what might be wrong with a particular social media post. And prior work have built techniques to improve the state of soft moderation on social media, such as identifying more and more posts that are candidate for soft moderation that are spreading misleading content. But we find that existing tools, they lack the ability to distinguish between posts that are either supporting the misleading narrative or refuting the misleading narrative. And in fact, we found that the existing tool, Lambretta, which was published in Oakland 23, it had a false positive of up to 20%, and this stems from the lack of ability to distinguish the context behind the post. So the objective of our work is we want to enable social media platforms to have contextual soft moderation. So what do we mean by that is we want to apply warning labels underneath the post that are only spreading the misleading content and not on the posts that are debunking the misleading content, which Twitter seems to do, as you can see on the right. And there are multiple motivations for this. So the first motivation was we want we want the public trust between platform and the user to be maintained at a high level, because in cases of public emergency, there might be public health authorities such as WHO giving helpful information and flagging this type of higher authority posts might lead to distrust between users and the platforms. And also we find that there are a lot of users that do the task of correcting misinformation in the platform. Applying warning labels underneath those posts, it might discourage the wisdom of crowds. And ultimately, if we have this contextual soft moderation system, we can take steps towards building much more fine-grained warning labels rather than the one that you are seeing, like a generic set of warning labels about problematic content. And also the major motivation of our work was when we did empirical analysis on the warning labels applied by Twitter during the 2020 US presidential elections. 30% of the tweets were actually debunking the content, and they were falsely applied with the warning labels. So the solution to this problem is a method from natural language processing known as stance detection, which given a piece of premise, in this case a social media post, and given a piece of hypothesis, in this case a claim that a platform wants to moderate, the goal is to whether the premise entails the hypothesis or the label is either favor, against, and neither. And despite stance detection being a well-established problem in natural language processing, we found multiple limitations of existing method that stop it from being applied for downstream soft moderation. So most of the methods that exist on stance detection in the field of NLP, they are topic-based. So what do we mean by topic-based? These methods, they deal with coarse-grained topics such as pro-climate change or anti-climate change, whereas the same techniques, when we apply them on social media posts that are discussing the details of the issue on a much more finer granularity, they fail to predict the stance. And the other limitation that we found was, in case we train finer grained stance detection models to begin with, a model that is trained on COVID-19 related claim, they fail to generalize on other type of claims such as election. And within the COVID-19 also, like there are multiple claims, this generality there is lagging. So we want to build a claim invariant solution. So we propose a new method for stance detection known as contrastive textual deviation. So previously, most of the stance detection method, they just take this sentence pair, a hypothesis and a premise, and they try to predict a binary classification. We extend this idea of stance detection by introducing this task, contrastive textual deviation, which we add this pair of contrastive markers, which are basically a supporting and a refuting example for the same claim. And we use this theoretical intuition that posts that refute the claim, they are deviating from the hypothesis statement, while those that support the claim, they stick closer to the messaging of the hypothesis statement. And by giving this additional set of contrastive markers, we want to perform stance detection on an unsupervised way. So before I go into the method, I'd like to highlight the data sets that we use. So we collect multiple data sets across 2 different social media platforms, Reddit and Twitter, and across multiple topics such as climate change, COVID-19, fact-checking, and election. And 2 of these datasets are curated by our team, and 2 of these are publicly available datasets. The goal here is to comprehensively evaluate this method on across a wide range of topics and across 2 different social media platforms. And as I mentioned, the approach here, it aims to, so most of the existing stance detection technique, for a claim, you would have to typically gather level data for ranging from like 100 samples to 1,000 samples for a claim, and you'd have to do it for every other claim. But our approach is for any claim, we just need this pair of contrastive markers. This is what the contrastive marker looks like. They're basically a positive and negative reframing of the claim that we want to moderate, and these positive and negative reframing, they require this hypothesis statement, which can be statements from public health authorities or fact-checking entities. And this is the only input needed by our system. And how do we realize this system? So the first step was we wanted to check this particular problem formulation works in case of stance detection. So we bootstrapped our tasks using a large language model, Flantify by Google. So Flantify, on a quick summary, it's a text-to-text transformer, and the method it employs is it treats every classification problem as a text-to-text classification problem. So that way we can use a generative model for classification. And how does our task looks like in the context of the Flantify LLM? So you can see we translated the contrastive textual deviation based triplets to this particular prompt structure, and given this input, we asked the LLM to classify whether the particular piece of text is supporting or refuting the hypothesis, and the only set of input needed is this triplet, which is hypothesis, refuting example, and supporting example. And in terms of performance, we found that bootstrapping contrastive textual deviation without any training, it can outperform existing stance detection techniques, both existing stance detection techniques that are supervised, which has seen a portion of the data. So this shows that an unsupervised technique is a good way to go about this problem. And the next step is we further went on and we fine-tuned this Flantify model for contrastive textual deviation. We already saw that this model is already good than supervised method. Why do we want to fine-tune further? There are a couple of reasons for that. Fine-tuning a model on a particular task, it can give even better performance. It can research has shown that it can make the model robust against adversarial prompts. And the major motivation was we wanted the model to be less sensitive to the quality of the triplets or quality of the input supplied to the system, and more focused on the downstream classification task. And because this Flantify model contains multiple million parameters, we had to use a parameter efficient fine-tuning technique. We have a much more detailed description of the fine-tuning procedure on our paper. I would encourage you to check that. And as we expected, fine-tuning this particular LLM on the contrastive textual deviation tasks, it further helped improve performance. And now we also evaluated this method against multiple other supervised and unsupervised techniques. And overall, our method, it gives us the best performance for stance detection across, this is a summary result for 4 different data sets across 2 different social media platforms. So now coming back to the original problem motivation, where our goal is to enable contextual soft moderation on social media platforms. So we tested how the integration on existing soft moderation system look like. So this is the envisioned pipeline. We start from a post that a social media platform already deems to be misleading, and from that we can first extract claims contained in the post. For this case, we use Lambda for the soft moderation system, but essentially our technique can be plugged into any open source or closed source soft moderation system that is being employed by social media platform. And then this contrastive textual deviation can be used as a filter to moderate only the posts that are spreading the misleading information. So this is what the end-to-end pipeline looks like. So we evaluated this against Lambda without the contextual soft moderation filter. So we are able to reduce the false positive rate of the system from 0.2 to 0.02, and this comes with a minor hit on the false negative rate, because when we are using this system, we'll be missing out on positive examples that are spreading the misleading information, but the false negative rate is negligible in this context. And here are some examples of tweets that the other tweets that were initially flagged by Lambretta, but using our contrastive textual deviation filter, we are able to identify that these are actually debunking the misinformation and these should not be flagged. There are other examples of this in the paper, and as you can see, the system does pretty good in terms of really challenging natural language text as well. So in summary, we proposed a new approach for unsupervised stance detection called contrastive textual deviation. We motivated this approach to be platform agnostic and event agnostic, and we thoroughly tested this on multiple different topics. And we also demonstrated how it can be easily integrated into existing soft immersion systems to reduce their false positives. And there are some limitations of our work, because we assume that for any claim that we wish to moderate, there is the availability of a triplet structure. And in case of newly emerging misleading narratives that might not always be available, in those cases we might have to detour to soft immersion system without contextual filtering. You can check out more details of our methodology in our paper, and all of our data sets and the model, they are hosted publicly on Hugging Face. Please feel free to check it out, and I'm open to questions.